Hello, Mr. Munyon here with activity 27-1 over circles on the coordinate plane. We're going to learn the equation of a circle and apply it. So in activity 27-1, our goal is to make sure we know how to derive the general formula for the equation of a circle. And go ahead and write the equation of a circle given 3 points. So we have a couple of goals. This one's going to be a little bit more work, and some of you guys may be familiar with the equation already because it's very similar to the distance formula. How can the path of a windmill be described mathematically? Suppose the coordinate plane is positioned so that the center of the windmill's face is at the origin. We know that a windmill rotates. The tips of the windmill will be creating a circle. So here we have an equation. It says x squared plus y squared equals 4, and it wants us to show given points on the diagram are on the circle by plugging them in to the equation. So all we have to do is take each x and y coordinate and square them and then add them together. So if I plugged in my x value was 1 squared is 1. Square root of 3 squared is 3, so 1 plus 3 does equal 4. That one works. Same thing here. 0 squared is 0. Negative 2, when you square it, becomes positive 4. So 0 plus 4 is 4. This one also works. On the other equation down here, we have a couple of points. Negative 5 squared is 25. Square root of 11 squared cancels out the square root. You get 11. So 25 plus 11 is 36. That one's on there. And 6 squared is 36 plus 0 gives us 36. So all of these points are on these equations, which kind of looks a lot like Pythagorean theorem. A squared plus b squared equals what looks to be c squared here. Same thing. Looks like Pythagorean theorem is going to help us with this a lot. So now it says consider the circle below, which has its center at 0, 0 and a radius of 5 units. Suppose x, y is a point on the circle. Use the distance formula to write an equation that shows the distance from xy to 0, 0 is 5. So I know the distance 5 equals the square root of x minus x1, so x2 minus x1, let's put 0 squared, plus y minus y1, whoops, okay, square both sides of this one, and we end up getting, because I don't need the minus 0 on there, I'm going to leave it in there. Okay, so we get x minus 0 squared plus y minus 0 squared equals 5 squared. On the next example, it wants us to consider a circle where the center is not at 0, 0, where it's at hk. So we can do the same thing, except for this time, instead of subtracting 0, the x value that we're going to be subtracting is going to be h, and the y value we're subtracting is k. But we can do the same thing, and we're going to leave just r as r because we don't know what those values are. So instead of a 5, we'll just use the radius of r. So use the distance formula, same thing. You square both sides, we get x minus h squared plus y minus k squared equals r squared. And this is actually the general form of the equation of a circle. So this is very important right here. We're going to be using this a lot over the next couple of sections. X minus h squared plus y minus k squared equals r squared. That is the general form of an equation where it tells us the center of the circle and the radius, which is all we would need to be able to graph it. Okay, so let's practice this now. Write the equation of a circle described. Pause here and see if you can both write the equation and identify the center and radius based on some information. All right, now that you've given yourself a moment to try questions 4 and 5, let's investigate. So we know the general form of the equation, x minus h squared plus y minus k squared equals r squared. All you have to do is plug in. So for this one, I get x minus 0 squared plus y minus 0 squared equals 7 squared, or you could put 49 on there. For the next one, b, I get x minus 0 squared plus y minus 2 squared equals 10 squared. For C, I get x minus 9 squared. So h is 9. K is negative 4. So for this one, I get y minus negative 4, I could write as plus 4. Remember, if you have y minus negative 4, minus the negative cancels out, and you can actually write it as y plus 4. So y plus 4 squared equals, and square root of 15 squared does just equal 15. So the square and the square root cancel out. You don't need to put a positive or a negative because we know the radius is a length that's going to be a positive value. So you don't need to put plus or minus when you square that one. Identify, number 5 says identify the center and radius. So this says x minus h. So h is 2. So the center is the x value of 2. Y minus k, if this was a negative 1, k would be 1, but it actually says the same thing as y minus negative 1. So that helps me realize that this is actually a negative 1 right here. An easy way to remember these is in the equation. It's the opposite of what it looks like in the coordinates. Notice it says x minus 2, but x is positive. Y plus 1, but y is negative. And then the r squared equals 9. You could solve for it. Take the square root, so r equals square root of 9, or r equals 3 on that one. It got kind of tiny there. So r equals 3 on that one. Okay, for the next one, I'll just put the answer and you can check and see if you did it correctly. Looks like we get the center is at negative 3 and 0 because nothing is added or subtracted, and r equals square root of 10. Not just 10, it's got to be r squared equals 10, and when you solve you have to do the square root on both sides. Okay, so then for number 6, let's apply it to a word problem here. Suppose the center of a windmill is not positioned at the origin, but at 2, negative 3. Draw a circle with the center at 2, negative 3 that contains the point 5, 1. So 2, negative 3 and 5, 2, negative 3 is the center. And 5, positive 1. 1, 2, 3, 4, 5, positive 1, not drawn perfect, is a point on the circle. Write the equation of any circle with a radius r and a center at 2, negative 3. So then writing the first part of this equation should be pretty easy. I know x minus h squared plus y minus k squared equals r squared. The center of the circle we already know is at 2, negative 3, so I could plug that in right now. However, to get the radius, you need to know the distance from the center of the circle to any point on the circle. So if I know a point like 2, negative 3, and 5, 1, I can do the distance formula to help me figure out how far the radius is. So it looks like 3, and what is this, 4? 1, 2, 3, 4. So if I checked 3 squared plus 4 squared, oh, this is just a 3, 4, 5 triangle. I get that the radius of this circle is going to be 5, or square root of 25 on there. So r equals 5. So I can plug in all of my pieces now. So x minus 2 is at the center squared plus y minus negative 3. So I can either put negative 3 or just plus 3 squared equals, and the radius was 5 squared. And you could write it like this or put 25. I like to write it like this. That way we just keep the radius right there. We don't have to take the square root to find the radius again. So you can put 5 squared or 25 on there. Now substitute 5, 1 into the equation and make sure that this is a point on the circle. Make sure it is a solution to the equation we just wrote. So let's plug that in. 5, if we plug in for x, so 5 minus 2 squared plus 1 plus 3 squared equals 25. So let's check and make sure 5 minus 2 is 3 squared plus 4 squared. And And sure enough, 9 plus 16 is 25. It does equal 25. So that means that that is a solution set. That is a point on this circle. Any xy coordinates that are solutions are points that are on the circle. So next one, C, says write the equation of the circle with center at 2, -3 that contains this point. We've already done that, right? Oh, whoops. I was supposed to do it with radius r up there, but we already figured out the radius. So oh, I guess part B was another way to find the radius. If you just know the center, you could plug it in and find the solution to get the radius. I guess that's another way to do that one. All right, let's look at number 7, see what mistake they made, if they did one. Wyatt made the statement that the point 2 square root of 6 lies on the circle centered at the origin and contains the point 0, 4. He gave the following proof. So radius equals 4, equation of the circle with the center at 0, 0. Looks like he made a mistake. Oh, yeah. Square root of 6 squared is not 12, so it looks like he did make a mistake right there. All right, moving on to the next problem. It says consider the circle that has a diameter with endpoints at -1, 4 and 9, -2. So I'm not going to draw these accurately on a coordinate plane, but I do want to remind you a diameter is a chord that goes through the center of the circle. So right in the middle, equal distance from each of those endpoints should be the center of the circle. All right, first you need to determine the midpoint. So average the x values and the y values. So 8, I get 4, and 2, I get 1. So that is the center of the circle. The midpoint is the center, so yeah. Okay, using one of the endpoints of the diameter and the center of the circle, write the equation of the circle. Okay, so I'm going to plug in one of the points. Let's write the general equation to make sure we're plugging in this in correctly. So x minus h squared plus y minus k squared equals r squared. Let's plug in, we have a coordinate here that we can use. For x and y, we're going to use a point that's on the circle, so we're going to use this one here. And for the center of the circle, we're going to use hk. So this right here is going to be h and k for the center of our circle. All right, so x is -1 minus h, so from the center of our circle, 4. Y is going to be 4 from up here, minus 1 equals r squared. So simplify, -1 minus 4 is -5 squared, plus 3 squared. So 25 plus 9 does give me 34. So then square root both sides, I do get r equals square root of 34. Right, it asks us to use the other endpoint, but we're not going to do that because we do get the same answer. We also get r equals square root of 34 when we plug that one in. So obviously we could use either endpoint of the diameter because both of them are solutions to the equation for the circle. So you can use, what does it tell you? You can use any point on the circle. So follow the steps below, write the equation of the circle that contains these 3 points. All right, so let's go ahead and graph these then. I'm going to zoom in a little bit, make it easier. Okay, so A is at -4, -1. B is at 6, 1, 2, 3, 4, 5, 6, -1. And C is at 6, 5. Okay, draw the chords AB and BC. So let's go ahead and draw these chords AB and BC. Next step says graph the perpendicular bisectors of each chord. So luckily these are vertical and horizontal lines. Perpendicular will just be a horizontal and vertical line here. And if the total distance is 10, that means 5 units would be the midpoint. So, and this one, the total distance, it went from -1 to 5, so 6 units, 3. And remember points of concurrency. This isn't a triangle, but what I just found, if this was a triangle, is the circumcenter, which one of the properties of a circumcenter is an equal distance away from all 3 points. So what that means is this point of intersection, the circumcenter, is an equal distance away from all 3 vertices of a triangle, or in this case, the radius of a circle. It's the same, obviously that's the definition of a circle. It's all the points that are the same distance away from the center of the circle. So now that we have this, what are the coordinates of the center of the circle? It looks like we're at 1, 2 are the coordinates. So the center is at 1, 2. All right. So the perpendicular bisectors is the way that we're able to use this one. So write the equation of the circle using the center and any one of the points. Okay, let's use A for this one. So I don't necessarily know the radius yet, but I can solve for it, and let's go ahead and do that. So x minus h, so -4, minus the center of the circle, x value is 1, plus y minus k, so -1 minus 2 equals r squared, so -5 squared plus -3 squared, so 25 plus 9. Looks like we end up getting 34 for this one, so r equals square root of 34 again. Interesting. Okay, so then now that we know the radius, you could write the general form of the equation as well. So x minus h squared minus 1 squared plus y minus 2 squared equals r squared. So square root of 34 squared is 34. All right, so that's the general form if we needed that one as well. Let's check our understanding. Let's see if you can do what we just did. Don't worry about number 10 right now. Worry about number 11. It says write the equation of the circles described, parts A, B, and C. Pause here, and when you unpause, I'll have the answers for you. All right, now that you've given this some time, let's check our work. All right, so for these, I decided to go ahead and go over. Number 11A was probably the easiest one, so I have the work shown here. If you got that one correct, great. If not, you feel free to pause and copy down the notes. Make sure you understand how that one's done. For 11B, I did want to kind of show or walk through some of the steps on this one. So let's go ahead and try 11B and make sure we fully know what we're doing on that one. All right, so it says it has diameter with endpoints, gives us the endpoints. To write the equation, we need to know the center and the radius. So first thing we need to do is find the midpoint of the diameter to find the center. So first step, use the midpoint formula. And we get 2 plus -10 is -8 over 2. And 5 plus 7 is 12 over 2. So we get -4 and 6 as our center. So the center is at -4 and 6. So now that I know the center, I should be able to figure out the radius by plugging in a point and the center into the equation x minus h squared plus y minus k squared equals r squared. And that way I'll be able to solve for r with whatever value I get over here. So a point that I can plug in here, x coordinate is 2 minus the center x coordinate is -4 plus 5 minus 6. So 2 minus -4, same thing as 2 plus 4 is 6 squared. 5 minus 6 is -1 squared. So 36 plus 1 is 37. So then r equals square root of 37. So now I should be able to just plug in the center and the radius into the equation. So x minus -4, contain minus and negative into plus and positive, plus y minus 6 squared equals square root of 37 squared. So square root and the square cancel out, you just get 37. So for B, 11b, we should get this equation here. All right, same thing on C, perpendicular bisectors, see what we come up with. All right, so for 11c, I went ahead and graphed the 3 points at -2, 5, -2, -3, and 2, -3. And remember, to do this, if this was a triangle, we could do perpendicular bisectors to find the circumcenter, and that point's going to be an equal distance away from all 3 points. That's what we want to do the center of the circle. So instead of drawing a triangle, I'm just going to go ahead and do the perpendicular bisectors of these. So this whole distance right here is 8, halfway is 4, and because this is a vertical line, they did this so to get some easy ones here. Same thing, this is 4 units across here, halfway in the middle is 2. Perpendicular is a vertical line, so the center of the circle is going to be at 0, 1 for the center. From here, you can figure out the radius. Looks like to any one of these points. I'm going to do a quick Pythagorean theorem here to find the radius instead of plugging it in like we do for some of the other ones. Looks like one of the legs would be 4 and 2. So I get a squared would be 16 plus 4 gives me 20. So the radius is just going to be square root of 20 if this was 4 and 2. A squared plus b squared is 16 plus 4 is 20. So square root of 20 would be that other side over there. So I know the radius and I know the center. I should be able to write my equation. X minus 0. Well, I guess I don't need to put that if the center is 0. You can put x minus 0 if you want. X minus 0 squared plus y minus 1 squared equals square root of 20 squared. Square and square root cancel out, so you just get 20 on that one. All right, for the last section in lesson practice here, I'm just going to go ahead and put the answers on these. That way you can check your work. Obviously, if you made a mistake on one of these, you might want to go back and watch the example that we did on it. All right, here are the answers for the lesson practice. Each one of these is kind of broken down by different examples that we did here. This is just with the center at the origin, different centers, finding the center and radius. And then here we have given a diameter or 3 points on the circle. We have examples of each one of these. So feel free to go back and check the video. All right, good luck with this. Till next time, guys.